Moving on to chapter 3, this first section is about extrema. And to sum up this definition, this really very formal definition in front of you of what extrema is extrema, if you remember from last year, is critical points. It's where something, a minimum or maximum on your graph, where that graph is changing for some reason. And what we do to find where it's changing direction, all right, if you think about throwing a ball in the air or something like that, all right, you're going to launch it up in the air, and at some point it's got to stop going up and it's got to come down, right? So what we're finding, that would be a maximum. That would be a critical point. Its highest point would be a critical point. So in fact, we know if we were to take the derivative of that ball's equation and set it to, if we take the derivative, we find out its velocity, right? The derivative of a position function is its velocity. Well, when the velocity equals 0, we know the ball is done moving up. So that would be it. We could figure out how long that took us. Then we could figure out the time that took us to go up. Then from that we could figure out how high it was in the position function. But what we're doing is we're taking the derivative of a function, setting that equal to 0. We want to find out where the slope of the tangent line is 0, because that tells us where the graph is changing directions, where it's moving from up, moving from a positive slope to a negative slope, or to a negative slope to a positive slope. So that's what we're doing in this section here. We're finding critical points, is what the book called it last year, and this year they call it extrema. The only reason they call it extrema, they're talking about minimum and maximum extrema. So that's to sum up this very formal definition. The last sentence here is important. A function does not have to have a maximum or minimum. So basically what that means, if it's not a closed interval, which means if it goes on for forever and ever and ever and ever and ever and ever, we don't know what its maximum or minimum is. It just keeps going. Okay. So here's another definition. If f is continuous, which means it doesn't have any jumps or anything like that, my closed interval from a to b, some point a to b, some x value from a to b, then it has both a minimum and a maximum on that interval. Well, if you think about it, if it's a closed interval, we know that graph doesn't go on for forever. If I just make any old graph like this and say we just want to look at the points from the y points from here to here, well, no matter what, it's got to start and it's got to stop somewhere, so it's going to have a maximum or minimum. All right, as long as this function is continuous, and this function doesn't have any jumps or anything like that. It's not discontinuous at any point. All right, so we know that, well, it looks like it's the highest here and the lowest here. All right, in order to find those, again, like I said, we're going to take the derivative, find out when the slope of the tangent line is 0, but that's how we take the derivative. All right, and set it equal to 0. Okay. And again, I summed up that definition right there. I gave you steps here for finding critical points. To find the critical points, take the derivative and set it equal to 0. Also, a critical point is anywhere that would make the derivative undefined. And then evaluate those critical numbers. Also, what we're going to do, we're going to evaluate each endpoint on the closed interval that they give us. Because it could start above. So we could have a graph that starts way up here and comes down here and does a bunch of goofy stuff that has some critical points or something like that, and then ends, I don't know, here. And where it started is going to be the highest point. So we got to evaluate the endpoints as well. All right. So here we go. Here's an example. I have 2 of them for you today. It says find the extrema of 3x to the 4th minus 4x cubed on the interval from -1 to 2. So if we were to graph this, I'm not entirely sure what it looks like. It's to the 4th power, so it's got to be a parabola of some sort. And so from -1 to 2, I'm sure it does. It probably does something goofy. I don't know what it does. Something like that. All right, what we're going to do is we're looking from the points -1 to 2. And we're going to figure out what the max and the min is through that point there. All right. So what we do is we take the derivative, and we're going to set it equal to 0. So f prime of x equals, we got to bring our 4 down, 12x, and subtract our power by 1 minus 12x squared. And to figure out what our critical points are, we're going to set it equal to 0. So 12x cubed minus 12x squared equals 0. Well, to solve this, I can factor out, they have a common term of 12x squared. So 12x squared, I'll pull that out. And I'll end up with just an x left over here and just a 1 left over here. In order to solve this, I just set both of these in equal to 0. 12x squared equal to 0 and x minus 1 equal to 0. So I get two values that are going to be my critical points for this graph. So I'm going to have x equal to 0 and x equal to 1. What we want to do now is we want to evaluate these points right here and figure out what their y values are, and that's going to tell us whether it's a max or a min. The highest one's going to be a maximum, the lowest one's going to be a minimum. We also have two other points that we need to evaluate, and we need to evaluate the endpoints. So we're going to evaluate 0, 1, -1, and 2. So we'll start at 0. Over here at 0. If I plug 0 into this equation right here, I have 0 minus 0. So my y value is going to be 0. My point is 0, 0. Well, I'll go to 1. 1 to the 4th is 1, so I'm going to have 3 minus 1 cubed is 3 times 4 is 4. So I'm going to have a -1. So y equals -1. Again, we're going to evaluate all the points, and we're going to decide which one's the minimum and which one's the maximum. So let's plug in our endpoints. -1. -1 to the 4th is a positive 3, or positive 1, and times 3 is 3. Minus then, -1 cubed is still a -1. So I have times 4 is a -4, across the line, change of sign. So I have y value to equal 7. And plugging 2 in to the 4th power, let's see here, 2 to the 3rd power is 8, so 2 to the 4th power is 16 times 3. I have, let's see, 18, 48. So we're going to have 48. I could have done that in my head. I'm not sure why I did that the long way. 48 minus, okay, so 2 cubed is 8. 8 times 4 is 32. So my y value is going to be 16. So now I take the highest value is going to be my maximum. So it looks like y equal to 16. So my point 2, 16 is going to be my maximum. And my lowest looks like it's going to be 1, -1. So that's my minimum. So those are the two critical points, or the two minimum and maximum, sorry, the extrema, the minimum and maximum for that equation right there. And I messed up there saying the two critical points. All of these are critical points. All of these somewhere, especially these two, is somewhere where the graph changes. All right, it changes from either going to a positive slope to a negative slope, or a negative slope to a positive slope. But both of those points here that I just marked, the derivative of the tangent, or the slope of the tangent line is 0. So we know it's changing. Something's happening in the graph at that point. All right. These other two are just endpoints. So, all right. Moving on to my last example for you. Hey, find the extrema of 2x minus 3x to the 2/3 power from -1 to 3. Again, it's a closed interval, so we're going to end up evaluating at the endpoints again. But we also need to find our critical points where something's happening on our graph. All right, so let's take the derivative and set it equal to 0. So f prime of x equals 2 minus, so I bring my 2/3 down. 3 times 2/3 would be 6 over 3, which is going to be 2x to the -1/3 once I subtract my 1 from it. All right, so let's go ahead. Set it equal to 0 and solve. So 0 equals 2 minus, let's do this, 2 all over x, the cubed root of x. If you remember, if we have a negative exponent, we bring it to the bottom of the division sign, the division bar, the bottom of the fraction. And let's solve this. I don't know, add our 2 over the cubed root of x over, and that equals 2 yet. Multiply our cubed root of x over. So I get 2 equals 2 cubed root of x. All right, and then I divide by 2, divide by 2. So I get 1 equals a cubed root of x. Cube both sides, and I get x equals a 1, being the critical point. But hold up, I also said at any point that would make x undefined, or make the graph undefined in our derivative. So a value that would make anything in the denominator equal 0 would make an equation undefined. So if we were to choose a number down here that would make this undefined, it'd have to be 0. So at x equals 0, it makes this undefined. You can't ever in a million years divide by 0. So those numbers are going to be undefined there. At 0, it's going to be undefined. So I have a critical point at x equal to 1, and x equals 0 because it makes my derivative undefined. All right, and then I also have my endpoints, x equal to -1 and x equal to 3. We're going to plug these in and figure out which is our max and which is our min. All right. So let's choose x equal to 1. If I choose x equal to 1, I'm going to have 2 times 1, which is 2, minus 1 to the 2/3 power. So 1 squared is 1. The cubed root of 1 is 1. So minus 3, I'm going to get -1. Plug 0 in there. I plug 0 in there, I get 0 times 0, which is going to be 0. I know that's happened in our last, these are my y values, by the way. In my last 2 examples, not always going to be 0, 0, by the way. Plug -1 in. If I plug -1 into my original, remember, keep in mind we're plugging these into our original equation, getting our y values, all right? So I'm going to plug it in to my original equation. I'm going to get -2 minus, then, let's see here, a -1 to the 2/3 power. So what that really means is -1 squared and the cubed root of that. So the cubed root of -1 squared, well, -1 squared is just a positive 1. The cubed root of 1 then is just 1. So I have 1, well, this is 1 times 3, so I have 3. So I'm going to get -5 for this answer right there. And then we're going to do x equal to 3. So when I plug 3 in here, I get 6 minus 3 times 3 to the 2/3 power. To maybe clarify a little better, I'll put it like that. So I have 6 minus 3 to the cubed root of 9, which is not an easy number, and I plug that in my calculator. I'm going to get -0.24 is what I'm going to get when I plug that. I plug this into a calculator because that is not a nice number at all. All right. So when I look at these, I got to decide which one's my minimum and my maximum. Well, my smallest number is -5, so there's my minimum. And my biggest number looks to be 0. And that's going to be my maximum. So there's our lesson for tonight about learning the extrema and the minimum, maximum, and critical points of a function. Where this is going to come into play is when we start looking at throwing a baseball or launching something and figuring out how high it went and how long it took to hit the ground and all that good stuff. So hopefully this makes sense, and come ready to ask questions tomorrow in class. Have a good night.